Good morning. I'm glad to be here. Timothy, it was wonderful that I will show some practical use to what you showed, and that's amazing. And I'm going to talk about how AI will impact the engineering industry, and I will go talk about a little bit about our story and show some example. So a little bit about SmartTech. So SmartTech is a technology company that doing optimization on-premise, dealing with raw materials, and in real time optimizing them, mostly known with the SmartVax system that reduce raw material by more than 30%, and now with the Smart Resin, MDI, PF, doing that more than 15% reduction. And I'm going to talk today about autonomous manufacturing, that dealing with the different raw materials, the virtual one, data, and what we can do with your data, and how can we optimize your production line with that technology, with AI technology. So when we started our journey around 8 years ago, we tried to focus on a couple of key factors that will really bring a different, really something that a little different than Industry 4.0. Trying to see what will be the future. So the first impact that we wanted to work with, we wanted to be proactive. We don't want to give just a graph and to let the operator guess what to do. We wanted really to close the loop and to give a real-time values into the line. The second point is, of course, understanding the production line and every different factories, mill, or facility have different challenges. So we need to define what are the critical areas that we would like to focus and work with you to define the question. Okay? AI brain, there is a lot of knowledge, but how to define the right question? That's something that we are working with the customer. Another point that Timothy mentioned, what's the impact of the human being? Okay? All the technology until Industry 4.0 include was dealing with the connection between the process and the machine. But going further, putting the human factor into the game, and how can we create that connection between the human, the operator, the key holders in your production line, okay, the process and the machine, bringing them together and creating the ultimate operator. Okay. And of course, we are doing all that in order to bring value. So when we are talking about value, we are focusing, of course, on productivity, cost, and quality, but there are other values regarding knowledge, regarding stability, that we wanted to also put into the game. So when we started to look at that, and we saw a huge number of production lines. Wonderful machine, wonderful OEM, wonderful machine builders, but at the end, the production lays in the end of the operator. And we saw that when the shift changed, every 8 hours, a new operator coming, and the first thing that he's doing is changing the set points. Okay, this is how I used to work. And those changes in the human behavior is sometimes irrational, and it can cause a lot of problems regarding productivity, regarding quality, regarding cost, regarding stability. Okay? And if we will be able to overcome that, we'll be able to create the ultimate operator that will basically stabilizing the line and will push the line much farther. And in order to do that, talk about the variance. So what we are mapping the HMI, we are mapping the connections between the machine that inflects the process, that's how the machine builder built it, and how the human reacting to that, because the operators have a lot of knowledge. There are guys with 20, 30 years of experience, okay? And how they do that, they have a lot of knowledge over there. Can we map their knowledge? Can we understand what they are doing good and what they are doing bad? Okay, regarding reward and punishment. So Can we take the massive data from the human interfaces, okay, and map those connections and bring that into the AI? But not only that, putting in the right questions, focusing on specific critical points and what we want to improve. Asking the questions, using the AI to build up the connection correctly, and then what we would like to do, we would like to reinforce those connections back, but manipulating them for our need in order to navigate to where I want the line to go. And by doing that, we are able to give suggestions from one hand to the operator what to do. This is where you want to go? Okay. I will tell you what segment to change. Not only that, if you feel comfortable, this is very important, if you can trust the AI, if you can trust the suggestion, then I will give you the possibility just to push a button and we will transmit those suggestions directly into the control system and basically close the loop with a reinforcement engine. And dealing with that, it's a huge challenge, and it's sometimes not a technology challenge. How can we create a trust between an AI to the operator? Because at the end, we are not here to replace the operator. We are here to enhance it. But with technology is well known, if you embrace that technology, you can get an advantage compared to others. And this is what we want to create. We want to bring an enhancement to the operator and bring them to the point that they will act as an ultimate operator. And I think also Oil Martin talked about that yesterday, and it's a very good So, in order to do that, we wanted to look a little bit different on the situation. We don't want to give graph to the operator to guess what to do. We want to give him a display that will tell him, this is where you want to go, we will define that. We will tell you exactly what to do, what to change. You can take your suggestion, try them, create trust, okay, and then push the button and let it stream in. And we are today the only company that really closed the loop in real time and making AI run a production line regarding a specific critical point. And of course, when we're doing that, we are mapping basically the human knowledge. And not only that, what are your questions? What are your targets? Okay, it's giving the management the possibility to be involved in the production, okay, if you know how to ask your question correctly. And regarding technology, we had to build something new. We had to build something that will run high speed, with small footprint, that will be close to the machine, to the OT network, that will be able to digest thousands of parameters per second, will be able to close technologically the loop. Okay, so we build up a small footprint box, what called smart box, with a AM framework. It's an open framework that is able to bring AI module on premise, and we are keeping all the data on premise. We are not transmitting anything to the cloud, because like a traditional AI concept that we are teaching the modules and then deploying the modules, here the line is always changing, and I will talk about that. And you need always to adapt, okay? Everything is changing, and in order to do that, we are bringing that box into the factory, and of course it's secure. You are not transmitting any data outside. So it's giving the project to be very, very short regarding terms of IT security and other issues. So when we look on the production line, there are different production lines. Okay, that's one of the points. But working with engineered wood, working with pulp and paper, working with food mills, and so on. So we understand that the production line is not fixed. Production line is a living, breathing organism. It's always changing because you're doing retrofits, you're changing machine, you're changing the raw materials, people are changing, seasons are changing. So, like a doctor, we need to listen to what's going on. So that's the point that we are putting in our box and basically tracking thousands of parameters per second of all the production line. But of course, building those connections, we need to focus on where is the challenges, where is your bottlenecks. Okay, if you're talking about OSB with a multi-daylight press, so that usually will be a bottleneck. So if I'm solving that bottleneck, okay, what will happen? Maybe the problem will shift to another one. So we don't want to, although we are collecting data from all the line, we want to focus on questions that we want to optimize. And in order to do that, our software is able to support a modular approach that we can bring in AI modules inside very, very fast to listen to the data core flow that we build and to learn the answer to the questions that we want to bring in. So for example, one of the modules is a smart press module dealing with counter press or multi-opening press. And when we bring it in the module, it's optimized in that part. And then the problem shifts to another area. And then we can deploy a different module that will be configured with the customer. And then we are giving a full approach to all different situations and problems and challenges and bottlenecks over the line. And the main goal is, of course, to optimize a different way. Now, a little bit examples. So, this is a project that we done in around 3-4 years ago in a multi-opening press, and it doesn't matter what is the equipment. Okay? You can attach to every equipment, okay? And we can get the data. So if you look on the performance, so you can see that the production of the line is around 180 square meters per minute. And there is a huge deviation. And if you look on the deviation also, you know, how the operator is working, so you see a huge deviation. And when we starting up our system, the first thing that the system will do, the ultimate operator will do is first minimize this deviation. Because if I can minimize this deviation, then I can push forward dramatically the production. I can push forward the production, and we push also the production in that line and increase total production of the line by 10%. Now, but you probably want to see how the system is looking, so let's look on that. So minimize approach, keep it simple to the operator. So we have here an example to a cooperation that we are doing with SimpleCAM. So we are attaching our box to control system of SimpleCAM, and we are reading thousands of tags per second, understanding what an operator is doing, and give him a screen that tell him, okay, those are the targets that you asked to be. Okay, now we will tell you how to go there. And in this drawing, we are pointing the set point that you need to change in order to achieve that. And I will show that in a minute. But when you feel comfortable, it's a suggestion mode. Try that. Feel comfortable with the AI. Then you can push the button, and that button we are integrated in this SCADA, and those values will transmit automatically into the control system. So the system is running fast. I'm running it pretty fast, but giving him suggestion, and you can work with that. And when you feel comfortable, you will push the autonomous mode, and those suggestions will transmit immediately into the control system, and basically stabilizing the line in around 15-20 minutes, and then pushing forward the productivity and minimize the cost in order to optimize the overall production. But keeping your targets stabilizing in a multidimensional equation. Okay. Where you want to go? How can I go there? How can I run it? And that is 1 hour run. Only 1 hour. That's the first 1 hour that you went into the autonomous mode. Okay. And think about what the system is doing, running 24/7. So at the end, we want to focus on business goals, of course. So we want to increase productivity. Okay, really increase productivity. Touch the line doing that. Improvement stability, because what you saw here, it's a 9-dimensional problem. Okay, you have the productivity, you have the cost, you have the quality, you have quality internal bond, MOR, density, you have sometimes belt mistrek issues. Define your challenges. Okay, those are the questions that we are putting into the AI, how to optimize that in real time. Okay. Enhancing quality and of course lower cost. And we are working with the customer to define those questions and to put that in our engines. So at the end, we call it Map New Factory because it's really here and it's happening, and we'll be happy to share more with any questions. Thank you very much.
We've got a few minutes before our break, and all of the speakers are up here. It's always tough to get that first question. The second one's easy, but usually I plan